For topic 6.5, we're going to discuss everybody's favorite piecewise functions. Now, we're not actually talking about this type of piece and wise, but rather we're talking about functions that are literally pieces that are linked together. And when pieces of functions are linked together, like you can see here, we have a piecewise function. They're defined by two or more equations that are given in a specific x interval. Do you remember these from Algebra 2? Let's dig into them a little bit more. Here we clearly have four different pieces of functions, and each one of them is a little bit different. For example, the function that's in red, that's a linear function. That would mean that it has a slope. That would mean it has a y-intercept. Now, if you wanted to describe that function, you could find its exact slope, and you could just count the rise and the run. It looks like it goes up 1 and over 1. That means that our equation starts to be formed by writing it as 1x. Now, the y-intercept is interesting because we don't really see it. We have to project the line up a little bit more, and if we project the line up a little bit more, I'd have to project it straight. That would mean my y-intercept is going to be at, well, I believe at 8. Now, the equation for that line would be x plus 8. But the thing is that it's not the entire line x plus 8. It's only the piece of the line that is to the left of this red dot. Now, this red dot is given by an x value of -5. And to say that we want to be to the left of -5, we would use a less than sign. And that would mean that we only want the piece of this equation that is less than or equal to -5. How about the next piece that you see here? It looks like a horizontal line. Now, horizontal lines are defined by just their y value. And so that horizontal line has a y value of 3. That would actually be the equation for that line. Except we don't want the entire line of 3. We only want the piece of that line that's between these two x values. Now, the first x value is where we left off at -5. But the next x value looks like it's at -1. So that means that I want the piece of that line that's between -5 and -1. Notice that I'm using a regular less than sign, at least I'm trying to, but I'm using a less than or equal to sign since my dot is filled in, since the point is filled in. How about this green piece? It kind of looks like a parabola. It's supposed to be. And that would mean that the equation for that would be some type of quadratic. We call it x squared. Now, it turns out that that quadratic has no shifting, so it's just going to be a regular x squared. But what I really want you to see is where the piece is formed. And again, it's formed between these two x values. Now, the x value to the left is also -1. The x value to the right would actually be an x value of 2. You see, you want to think of that parabola as being between -1 and 2. And we can say that once again using inequalities. Now, notice again that I am using a less than sign because it's an open circle, but I'm going to use a less than or equal to sign at the end of that parabola because it actually equals that point. Now we have one last piece. It's this purple line, and it's another line that has a slope. This time it turns out that if you count the rise and the run, you would count down 2 and over 1. That means it has a slope of -2. So we can write that equation as -2x. Now, it also has a y-intercept, but we have to go backwards to find it. And if we go backwards to find it, I believe we will end up back up here at this same y-intercept of 8. So I can write the equation as -2x plus 8. Except that would be an entire line. That would be a full line. I only want the piece of the line that starts at this x value. And again, it's actually the same x value where the other piece left off. It's an x value of 2. Now, because the graph is going to the right, we would say that we want to be greater than 2. And when we say negative 2x plus 8 for x is greater than 2, then we end up with just a piece of that line. Now, what I just created over here is a piecewise function, and it's very colorful, but when I put a bracket around it, it actually says that all of those pieces get put together to make that one function. Why don't we see if we can graph a piecewise function? When you graph a piecewise function, you definitely want to clearly show the sketch, its behavior, meaning the direction of the graphs, and then we want to make sure that we're showing special points, typically endpoints, starting points, maybe some other point that's helpful in the graph. Now, it can be nice if we have graph paper. If you have that ability, you can use graph paper. You can also just make it a sketch. This one I'm going to put on graph paper. It makes it a little easier to graph each of these lines. And that's what this is, right? This first one, 2x plus 3, that's going to be a line. And we know how to graph a line. We know that we can start at the y-intercept of 3. And if it has a slope of 2, we can go up 2 and over 1. Now, what I'm doing here is I'm kind of getting a general sense of what this line looks like. The reason I say I'm getting a general sense of what it looks like is because I know that I'm not going to end up graphing this entire line. So we're kind of making it a little bit of a dotted line. In fact, I only want to graph the part of the line that's less than or equal to 1. Now, what I like students to do is I like them to find that endpoint. What endpoint? Well, the endpoint that you would get when you plug in 1. Now, when you plug in x equals 1, you get 2 times 1 plus 3. That comes out to be 5. That is a very important point. In fact, that is the starting point. And at this point, no pun intended, I'm going to highlight that. I'm actually going to also label it, even though it's clearly shown on the graph. And that way, when I draw my graph, it'll start at 1, 5. And of course, which way do I want to draw the graph? Well, I want to draw it less than. Now, less than, because I have a less than sign right here, less than means left. And so we start at this point, and we now draw our entire, well, I shouldn't say entire, but we draw our line from the point 1, 5. And maybe more importantly, I also get rid of the rest of that graph because that's not part of that piece. How about negative x plus 4? Okay, sometimes I find that students forget the basics, and the basics would be that negative x plus 4 is a line that has a y-intercept of 4, and it has a negative slope. So if I have a line that has a negative slope, I can kind of go down 1 and over 1, shown by these dotted lines. Now, if I want to, I can kind of sketch lightly, maybe with dashed lines, maybe just with those dots that I put there. I'm having trouble drawing these dashed lines. But I can kind of lightly sketch these dashed lines, so then I can think about the starting point. And how do you get the starting point? You plug in 1. For this problem, you plug in 1, and that would, of course, be negative 1 plus 4. Now, that comes out to be 3. Don't panic. The point 1, 3 is actually on my graph. It's right here. And, in fact, it's not the same as where the other piece left off. And that's okay. Okay, nobody said that the pieces have to connect. In this case, my point 1, 3 is actually a little bit below the other graph. And I want to draw the greater than side. Now, be careful. Greater than means to the right. So when I actually draw my graph to the right, I'm only going to be drawing this piece. In fact, that means that I'm going to be erasing or getting rid of the rest of these dots that I put down so that I can end up with just the piece of the line that goes to the right. I erased a little bit more than what I wanted to there. Now, to take care of some details, we want an open circle. We want an open circle right there at 1, 3, right? So what I want to do here is I want to make sure that I put an open circle at that point. And again, I'm kind of having trouble here because I actually want to erase some of that. There we go. And we can fill that, or we can draw that circle, but not fill it in. All right, so I have two pieces. I have a piece that goes to the left, that's in red, and I have a piece that goes to the right. That's in green. And I've labeled the starting points and clearly shown the behavior of those two graphs, which basically are just graphs that have some slopes. How about this piecewise function? Negative 1/2 x squared for x is less than 0, and then the square root of x. Now, before you get a calculator out, you should be able to graph these pieces. Even though we're not drawing it real technical on graph paper, we should be able to graph a negative 1/2 x squared. Remember from our last lesson, that's just a parabola. It's actually been reflected down, and it's going to feel like it's been stretched horizontally. Can you picture a parabola like that? Sure, it would kind of look like this. And again, it's just a sketch, so that's pretty good. By the way, the vertex, well, would be at 0, 0. That's because this parabola did not shift. Now, I want the part that's less than 0. Less than 0 means to the left. So I'm going to now be able to draw over top or actually graph the part that goes to the left of my original dashed line. Taking care of some details, as we talked about in the last problem, we actually want this to be an open circle since it's not equal to 0. And that's a pretty good job for drawing that piece. It's just a sketch this time. How about the square root of x? Remember what that graph looks like? The square root of x. Well, the square root of x is always a graph that has this basic shape. And it turns out that by default is going to be for x is greater than 0. So I really don't have anything to erase, and I don't have anything else to add to this. Also, I'm not going to fill in the circle, since this one is just a plain greater than as opposed to also being equal to. So it looks like we're done with that graph. All right, how about this last piecewise function? 3x, or 3 minus x for x is less than or equal to 1. And then we have x squared plus 1 for x is greater than negative 1. You want to try this one on your own? If you do, I encourage you to pause the video right now. See if you can make a decent sketch of this. If you don't want to try it on your own, then you're just waiting for me to continue, which I will do here in 3, 2, 1. All right, well, are you real surprised? The first equation is, of course, a line that has a y-intercept of 3. Now, it does have a negative slope, so you want to be careful that you're kind of picturing a line that has a negative slope. Lines with negative slope go down 1 and over 1. I can also go backwards. I can proceed to the left side. But I think it's important to just kind of get a general feel for the shape of that line, and in this case, the tilt of the line. Now, when we get down to the details, we would be plugging in negative 1. This is an important idea because when you plug in negative 1, you get the y value that goes with that. Be careful, that's going to be 3 minus negative 1. Of course, that comes out to be 4. What's negative 1 for? Well, negative 1, 4 is a point on this line. It's an important point too because it's actually the starting point, or as some people call it, the end point. But it's the starting point where I'm now going to draw the less than side. Now be careful, less than does not mean going down. Less than means to the left. Which side of this line is to the left? Well, you can tell. It's definitely over here. But I'm telling you, it's a real common mistake for kids to want to draw this side because they see the line going down. Okay, again, less than means to the left. I actually end up getting rid of the rest of this line, right? I end up getting rid of that so that I only end up with a piece that starts at 1, negative 4 and then goes to the left. How about x squared plus 1? X squared plus 1. Okay, now remember, that's a parabola. That's a parabola that did a little shifting, right? It shifted up 1. Maybe I want to label that as like a vertex. Okay, now the shape of a parabola, you know, it's going to be this basic shape, but I want to be careful how I connect the pieces. In fact, for this particular problem, we find out that when we plug in negative 1, now remember, you're plugging in negative 1 to get the y value. That's negative 1 squared. That's not equal to negative 1. Remember, negative 1 squared is positive 1. And that ends up being of course, a y value of 2. What is a y value of 2? Well, it's the starting point of this parabola. And since it's going to be a greater than without an equal to, it's going to have to be an open circle. So we draw an open circle, and then we go ahead and sketch the rest of the parabola. Of course, it's to the right since it's greater than. Okay, so we end up with a diagonal line that's shooting off to the left. We end up with a parabola that looks a little bit cut off, and there's this space in the middle. And you'll learn a little later this year, real simply, that we call that a jump. We call that a jump because that's exactly what you would have to do to move from piece to piece. What if I want to evaluate this piecewise function? This is going to be our last little topic. I just want to make sure you understand that evaluating, like it's always been, is just plugging in. Except you got to make sure that you plug into the correct piece, and you got to understand that you're still going to only end up with one output. So we're going to plug into this piecewise function so that we can get basically a evaluation. Now, when you're given a problem to evaluate, it's going to look a little different. You're going to see this function notation. You're going to see this, for example, f of 2. And when you see something like f of 2, you have to say to yourself, okay, that just means I'm plugging in 2. Now, everybody can plug 2 into this, but you just have to make sure you're plugging into the right piece. You see, one of the pieces only accepts numbers that are less than -1. The other piece accepts numbers that are greater than -1. So what about the number 2? Well, the number 2 is definitely a number that's greater than -1. So it has to be plugged into the x squared plus 1 piece. And it's real simple to do. We're just going to plug in, we're going to plug in the number 2 for x. We're going to square it. We're going to add 1. And again, everybody can do that. It's going to come out to be 5. But what I want you to understand is that that means when x equals 2, f equals 5. In other words, there's a point over here. It's not necessarily a special point, but there's a point over here called 2, 5. Okay, now it'd be silly to also plug that into the red piece because that piece doesn't use the number 2. That piece doesn't accept the number 2. What if we want to plug in -3? What type of x value is -3? That's right, it's an x value that's less than -1. And that means that we're going to plug it into the linear piece. And again, everybody can do this. You're just going to plug in -3. Make sure you do it carefully because we end up with 2 negative signs. So we have plugging in -3, we end up with 3 minus -3. And of course, that comes out to be 6. What does that really mean? Well, that means there's a point over here on this red piece at -3, 6. Okay, but again, there's only one point. That's because we only plugged it into one piece. And anytime you do an evaluation problem, you want to make sure you're doing the same thing. Just plug it in. You get one y value to match with that x. All right, piecewise functions. Now it's your turn. You're going to graph some of these for homework. You're going to write a couple equations like we did in the first example, and I'll probably even have you evaluate a few, but that should be pretty easy.